I'm Jordan Scott with US Glass Magazine, and I'm here on the 11th floor of 2112 Penn, admiring the beautiful view of Washington, D.C. This building project is being developed by Skanska, which worked with architecture firm Gensler on the design. I got the chance to speak with representatives from both companies about the importance of glass to preserve natural light and maintain this view for 2112 Penn's future tenants. Can you tell me about the design intent of this project? Were there certain aesthetic and performance goals you wanted to achieve?
Ultimately, one of the biggest challenges or maybe opportunities ended up being that this was a mid-block building. So we have buildings on east and west. So we wanted to create an interesting architecture that takes the typical glass box and turn it into something that is dynamic. So the fins are actually the main feature, but the beauty of it is that once you see it as a big composition, it takes a static facade and makes it into a very dynamic facade that keeps changing during the day.
So when we started working with Gensler, what was really intriguing for us is the way they used glass as a sculptural element. And if you look at the outside of the building, they used the glass fins to create kind of a movement, almost a wave. It creates a very different architecture on Pennsylvania Avenue, but it also responds to what tenants are looking for, which is as much daylight and views as possible.
What type of glass did you choose to use for this project?
Obviously, the performance is based on heat and cooling loads. So we are in consultation with our MEP engineers. But ultimately, the glass selection, once we achieve those performance criteria, is really about aesthetic. So the reason I gravitated toward this VE12M glass from Viracon was the least amount of exterior reflectivity, because what we didn't want was the building envelope glass itself to start competing and reflecting the fins, where then you actually really start losing the strength of the fins because they get muddied down as they keep reflecting themselves on the glass. We really wanted this to be as clear as possible, so we had it with a low iron glass, but when we did the cosmetic or aesthetic comparison between low iron and regular glass, frankly, the difference was so insignificant, so we decided to even forego the lower iron.
The wave effect produced by these glass fins creates an impressive view for those passing by the building as well. The designers took great care to ensure that the light given off the exterior is stunning rather than overwhelming.
Now, typically when we put this out on buildings, they're clear or maybe low iron, but there's nothing that actually catches light because it's all clear glass. So since our intent was to actually make the fin into a design feature, and doing this white ceramic fritz was the right tool. And adding the stainless steel cap on the end that gives you that shiny moment that catches light. And by using straight edge fins, as they transform from one fin to the other and the shape starts moving, that undulation, which was always our design goal, was to get something organic while we're using something very geometric.
What design challenges did you face?
One of the biggest challenges with this skin design was the fin and stability of the fins as they're anchored into the main body of the glass. Well, in this case, we start from 4 inches at the minimum, and we actually grow it to 20 inches at its deepest moment. The first options were all mechanically fastened. And when we saw the result, the end tip of these fins were actually oscillated about maybe maximum of 3/4 inch left or right, which is a non-starter for this design, because that rattle is eventually going to affect the mullion system, the glass, and every part of it. So that was a non-starter. So working with Pioneer, who was designing the system, we ended up doing a gravity connection by fluring out the male and female on the receiving and the embedding portion of the curtain wall. So once these glass fins are set in place, the gravity takes over. And if you can actually reach out and touch the tips, you could not move it without literally twisting the mullion system itself. And the other innovative part is we have a glass corner on the northeast side. However, we had a perpendicular fin that was actually landing into a 45 mullion. Now that connection is very difficult to develop because the water lines want to be in different places. So thanks to Pioneer and their innovation, they were able to actually make that work.
The developers hope to keep this view throughout the life of 2112 Penn. They use measures to prevent future development from blocking the glass.
Well, certainly the location of Pennsylvania Avenue is unique, and because it's a wide avenue, there's access to a lot of different views to the northwest and down Pennsylvania Avenue and I Street, and those are things that we wanted to maximize. Along the west side of the building, there is opportunity for redevelopment in an adjacent building. So we were actually able to work out with the university the opportunity to set back any future adjacent building to preserve those views. So the glass would wrap around Pennsylvania Avenue all the way around the back of the building and continue those sight lines down towards the White House and down I Street, which really are great views when you get up on the upper floors.
For more about projects like this, check out NEWSCAST magazine and usgnn.com. I'm Jordan Scott. Thanks for watching.